Morning. Sorry can't be with you guys today. Got called for jury duty, so I thought I'd run in and just get a few problems done so that you have something else to look at before you try some of the assignment problems for the chain rule. So what I'd like to jump right back into is finding a derivative of a composite function. So two different functions going on at the same time. So here on this example, what we have is a trig function going on inside, and then we have a power on the outside. So two different functions happening at the same time. All right, now our first method that we could use for finding the derivative of such a function is called a u substitution. And what we can do is we can replace part of the original function with u, which allows us to then find its derivative. And so in this example, what we could do is we could replace the sign with u, which means when we make the substitution, instead of y equals sine to the fourth, we'd have y equals u to the fourth. Now, of course, we know how to take the derivative of u to the fourth. That's just going to be power rule, so we'll drop down in front and subtract 1. But unfortunately, there's a catch. The catch is that every time we take every time we use a u substitution, we also have to take the derivative of the substitution. So we have to take the derivative of u, which is 1. We have to take the derivative of sine, which is cosine. And then for everybody who was in class yesterday, we attach what are called differentials. And differential, again, is just a reminder as to what variable we just took the derivative of. And the differential is going to be a lowercase d followed by the letter that we took the derivative of. So when we take the derivative of u, that's actually going to be 1, and then we attach the differential du. The derivative of sine of x is cosine of x, and then we attach the differential. Okay? All right, back to the original problem. Y equals sine of x to the fourth becomes y equals u to the fourth. Now, very easy to take the derivative, but once again using differentials. The derivative of y is 1, attaching the differential. The derivative of u to the fourth is drop down in front, subtract 1, so 4u to the third, but once again attach the differential. Okay, now since our original problem started off as y in terms of x, y and x, we want our answer to be in terms of dy's and dx's. And of course, right now we're in terms of u's and du's. So we need to switch back. And we switch back by replacing u with what it's equal to. And of course, going back up to the substitution, u is equal to sine of x. But we also have to replace du with what it's equal to. And you can see du is equal to cosine of x dx. And if we just take one little algebra step, which is dividing both sides by dx, on the right-hand side, the dx's cancel, but on the left, we have dy dx equals, and then we have 4 sine of x to the third times cosine. And we have one of our basic notations for derivative right here. We have dy dx, one of our basic ways in which we've expressed a derivative. Okay? Now, before we move on, I want to just point out one small thing. In fact, I'll change to red so it's easier to see where I'm at. I just want you to notice that the way I wrote the function originally was with parentheses, but if you remember your pre-calc, this would have been the same as sine to the fourth of x without the parentheses. Therefore, another way to write our answer would have been 4 sine to the third without the parentheses, cosine of x. So just wanted to point that out, that those are equivalent. Okay, that's again an example using a u substitution. Okay, but I want to now introduce you to a much quicker, much more efficient way to do problems involving derivatives of composite functions. Okay, and this is called the, I better switch back to black, there we go. This is called the chain rule. This is called the chain rule. It's It's the rule that we use for the derivative of composite functions. All right, and the rule just simply looks like this. The rule looks like this. If capital F of x equals little f of little g of x, so we have our composite function, then the derivative of capital F is going to be the derivative of little f, leaving g alone, multiplied by the derivative of g of x. That's called the chain rule. That's called the chain rule. What we do is we take the derivative of the outside function, leaving the inside function alone, and then we multiply by the derivative of the inside function. Okay? All right, maybe in a different way, I could write this out. I don't know if this would make any more sense. Just take a look, see what you think. If y is equal to f of cloud, then dy dx is going to be equal to f prime of cloud. The inside stays the same, but then we have to multiply by the derivative of cloud, right? It's the derivative of the outside, leaving the inside alone, times the derivative of the inside function. That's called chain rule. And if we go, and feel free to pause the video at any point if you need to jot things down or look at something closer. But if we go right back to the problem we just did to start this video, that y was equal to sine of x to the fourth, and we want to go directly to the derivative without u substitutions, without differentials, and all of that jazz. What we have to identify for ourselves is what's inside, what's outside. Okay, now the way this is written, I think it's pretty obvious that the inside function is going to be the sine. The inside function is going to be the sine. Okay? The outside function then has to be, the only thing that's left, the 4. The 4. Okay? So what the chain rule says is, take the derivative of the outside function, leaving the inside alone. Then multiply by the derivative of the inside. So since the outside function is a power of 4, the derivative when the power is 4 is drop down in front, subtract 1. That's how we take the derivative of something to the fourth. Drop down in front, subtract 1. Now what the chain rule says is leave the inside function alone. All right? So we drop the 4 down in front, subtract 1, leaving the inside function alone. But then what we have to do is multiply by the derivative of the inside function. The inside function is sine, so the derivative of sine is cosine. Okay? So, kind of in combination here, what we have is the derivative of the outside function, leaving the inside alone. Notice the inside just stayed the same. And then we multiplied by the derivative of the inside function. And if you look back, you can see this is exactly where we ended up after the u substitution as well. But with chain rule, we can get there essentially in one step. Okay? Again, feel free to pause the video if it's moving along too fast for anybody. Now, yesterday we did a couple other examples. We did a couple other examples of derivatives. And one was something like this. I think I changed it up last minute. I think I used Jackson's age, I think. So I think I went something like this. If it's off by a little bit, sorry, but it's very close. Again, we did this one with the u substitution. Now I just want to show you how to do the same thing with chain rule. What you have to do again is for yourself identify the inside function. I hope that's pretty obvious. It's going to be what's inside the parentheses. And you have to identify the outside function, which once again is just this power. What chain rule says is, to find the derivative, we take the derivative of the outside function, and since the outside is a power of 18, The derivative for a power of 18 is to drop down in front and subtract 1. So drop 18 down in front and then subtract 1 from 18. Now what we have to do is leave the inside function alone. Leave it alone. Don't do anything to it. But then multiply by the derivative of the inside. The derivative of the inside function, the derivative of x squared minus 5 would be 2x. And to simplify then, the 18 and the 2 would give me 36. I think I'll pull that single x out front. Doesn't matter too much. And then what I'd be left with is x squared minus 5 to the 17th power. And there is our derivative. Okay, again in really 2 steps, I guess, with the simplifying done. Okay, and the other one that we did yesterday, using a u substitution, but now I'll just show you the same problem with chain rule, was this one, I believe, tangent of 8x squared. Okay? Again, we want to be able to go to the derivative in one step instead of doing all the u substitution. Okay? And now, which one's the inside function, which one's the outside? Again, the parentheses are awfully helpful here. So inside the parentheses, the 8x squared is going to be the inside function. In other words, the angle on the trig function is the inside function, and therefore the outside function is the trig function, the tangent. Right? So we have inside and we have outside. So what chain rule says is, take the derivative of the outside function. What's the outside? Tangent. So when you look at your basic rules, what's the derivative of tangent? Secant squared. But we have to leave the inside function alone. So the angle, the inside function, stays the same. But then what we have to do is multiply by the derivative of the inside function. So the derivative of 8x squared is 16x. So secant squared is the derivative of the outside, leaving the inside function alone, 8x squared. Then we have to multiply by the derivative of the inside function. Now, again, to get full credit, I'm going to push you to pull this 16x out in front of the trig function so it doesn't accidentally become part of the angle at some point. And so our derivative would then be 16x times secant squared of 8x squared. And as I've mentioned a couple of times, but I'm just going to continue to repeat it, whatever the angle starts off as on the trig function, 8x squared, it should always end up, the angle on the trig functions should always end up the same. That son of a gun should never, ever change when you take a derivative. Okay? All right, so those are the same ones that we did earlier with u substitutions. And now for the next few minutes, I'd just like to do some more examples of chain rule. So feel free to jot down as many as you wish. Okay, the next one, p of x is equal to 1 over the square root of 8x squared minus 3x. Okay, and I'd like to find the derivative of that function. Now our issue here is we don't have a specific rule for radicals. So therefore, before we take the derivative, we have to do a little bit of algebra. And what we can do is we can replace square root with 1/2 power. Then I can pick up the binomial that's in the denominator and move it to the numerator. And when I pick up the denominator and move it to the numerator, the positive 1/2 exponent becomes a negative 1/2 exponent. Okay? And then the question would be, can you see what the inside function is? Once again, the parentheses are the giveaway. And can you see what the outside function is? Okay? So the derivative is then going to be derivative of the outside. So drop down in front, subtract 1. So drop negative 1/2 down in front and subtract 1. Negative 1/2 minus 1 is negative 3/2. Leave the inside function alone. Then multiply by the derivative of the inside function. the derivative of 8x squared and the derivative of negative 3x. Notice there's no exponent. Let me use a highlighter. Please notice there's no exponent there. It's gone, all right, because we've already taken the derivative of that in the first part of the problem. Okay? Then we're about done. I mean, we could leave this as our answer, but I just want to show you that we could simplify this, and just thought I'd show you at least one way that we could simplify this. We could have the negative 1 from the fraction, the 16x minus 3. Then we'd have a 2, and we could write 8x squared minus 3x. And since I put that back in the bottom, the denominator, the negative 3 halves could become positive. Now that's not the only way to simplify, but that's one way in which we can come up with a pretty darn nice answer. Okay? All right, just a couple more. Again, feel free to pause the video if you need to take a closer look at any of these. Another example. Let's see, I'll go with this one. R of x is equal to cosine of 3x squared plus 2x. Okay, another trig function and a binomial. Again, inside, outside. Within the parentheses, kind of the giveaway, that's the inside. Therefore, the trig function is the outside. Right, so the derivative, using chain rule, the derivative of r, using the chain rule, is the derivative of the outside, leaving the inside alone, times the derivative of the inside function. So here we go. The outside function is cosine, so the derivative of cosine is negative sine. Leaving the inside function alone. And then what we have to do is multiply by the derivative of the inside function. So the derivative of 3x squared plus 2x would be 6x plus 2. And so that the 6x plus 2 doesn't become part of the angle, I would require that you guys pull that out front of the trig function. And even though the angle on the trig function had a binomial, even when we've taken the derivative, that same angle binomial is still there. Again, the angle on a trig function never changes when we take a derivative. Okay? Let's see, I'm just looking for one that's maybe a little bit different. The video's going kind of long. I hate to do too many. Ooh, boy, that's a tough one. Well, here's a tough one. Here's a tough one. W of x is equal to sine of x. So it's a trig function made up of another trig function, sine of x. Please notice it's not sine times sine. It's not this. It's not the sine of x times the sine of x. It's not that. It's the sine of x. Okay? And so to find the derivative, we want to identify inside, outside. So the inside function, again, parentheses are kind of the giveaway for right now. So that would be the inside function, and therefore this sign is the outside. So the derivative is going to be derivative of the outside function, leaving the inside alone, times the derivative of the inside function. So here we go. The derivative of the outside, the derivative of sine is cosine, but not cosine of x. We have to leave the angle, the inside function, alone. Then multiply by the derivative of the inside function. The derivative of sine is cosine. And no simplifying could be done here, so this would be our weird-looking derivative. Weird-looking derivative. Okay? And I think I'll finish this video. I don't want to give you guys too much to have to sit through, but I'll do one more. And I'm going to make this one kind of about as hard as I can make it. So I'm going to call this one h of x is equal to the tangent of 4x squared minus 2x cubed. And this one's going to be a really hard one because it's not really a two-piece composition. This one's actually a three-piece composition. There's really three things going on. We have a tangent function, we have a binomial, and we also have a power. So it's actually a three-part composition. And so what we have to do, I'm just going to scooch over to the side a little bit. What we have to do is understand that instead of a two-part composition, if we have a three-part, if I have f of g of h of x, so I have a three-part. I have an outside, I have a middle, and I have an inside. Then the derivative is going to be, we start on the outside and work ourselves to the inside, is going to be the derivative of the outside function, leaving the middle and inside alone, times the derivative of the middle function, leaving the inside alone, times the derivative of the inside function. So it's the derivative of the outermost function, leaving everything else alone, times the derivative of the middle function, leaving everything else alone, times the derivative of the innermost function. So outside to inside, outside to inside. So in our example, tangent of 4x squared minus 2x to the third, the tangent is going to be the outer function. The power of 3 would be the middle function. And the 4x squared minus 2x would be the inner function. So the derivative of the overall function is going to be derivative of the outside. Derivative of tangent is secant squared. Everything else has to stay the same. So the 4x squared minus 2x to the third power has to stay the same. So we've taken the derivative of the outside, left everything else alone. Multiplied by the derivative of the middle function. The middle is the power of 3. So to take a derivative of a power of 3, we have to drop down in front and subtract 1. So therefore, we have to leave the inside function alone. And then finally multiply by the derivative of the inside function. So the derivative of 4x minus 2x would be 8x minus 2. Okay? So you look at that and think, oh gosh, that's a tough one. All right, but that is a three-part composite function, and that's how we'd find the derivative. Now in this one, with the power of 2 here, the power of 3 here, not a whole lot of simplifying I could do other than, if I wanted to, I could distribute the 3 indoors. So I could write 3 times 8x, 3 times negative 2. Other than that, though, and that's not very important that you do that, it's not worth foiling and multiplying everything else. Other than we should write the secant at the end, right? And that would be our derivative. Okay, so I'm just going to call it a day there. I know you have a decent amount of time. Hopefully you can try some of these on your own. You can help each other out the best you can. And then I hope I'm back on Wednesday. I'm hoping I'm back on Wednesday so that we can go over more of these together. Okay, so I hope you're having a good day. Help each other out, and we'll hope to see you soon. Okay, bye.